Hi, welcome to course number 2. This course will be all about Oasis Emerald, our EVM compatible blockchain. So we will talk how you can deploy your dApps on Emerald ParaTime and how you can use some tools that will help you ease your life and to make sure that your projects will be deployed as fast as possible. We also will introduce some demos with some useful smart contracts and useful services that you can use later on for your project, such as band protocol, such as how to create your first NFT, and also how to use, for example, Truffle to deploy your smart contracts to our testnet. So let me show you the agenda for this course. This is our course flow for Emerald. And for the beginning, we always start with some module 1 where we do some overview of our product, our Emerald ParaTime. And then we will show you, because it's a must, that users and developers understand how to transfer assets to Emerald ParaTime and how to use block explorers to investigate or dive deeper on transactions, on smart contracts, on everything happening on the blockchain. Now, with module 3, we will show you the tools used preferably by developers to build on any EVM chain or Ethereum actually. And these tools are used to deploy on Emerald also, right? And then we will continue with module 4, which is actually how to integrate Band Oracle Smart Contract, because you can use this Band Oracle to get some real-time prices if you want for your application. Let's say real-time price for BTC, for ETH, for ROSE, right? And last but not least, we will introduce how to create an NFT, basically an ERC 721 token, and let's say mint NFT on Emerald ParaTime. So enjoy this course and see you in the first module. Hi, welcome to module 1. My name is Gasper and I'm developer relations lead at Oasis Network. Today I'm going to show you how Emerald ParaTime looks like and where it fits into our architecture. So we will talk about some parameters, some initiatives for running a node, and also what actually EVM blockchain is. Okay, so let me start with the first one, which is the architecture of our network. So first of all, we have so-called consensus layer on the top, let's say, and we have ParaTime below. Or even if you switch that, so we have layer 1, this is our consensus layer, and then we have layer 2, or you can call that layer 1.5, because we have so nice integrations and you can transfer really fast with instant finality all your rows from consensus to paratimes. So to make that clear, right, we have consensus layer which is scalable, it's robust, and it does not support really smart contracts because we want to keep it secure, we want to have high throughput, and that's why we have clean, robust consensus layer 1, isolated from all other computings. Now, in the layer 2, right, we have so-called paratimes. Those are actually parallel runtimes where all the computation is done, and guess what? All these paratimes are isolated from each other. Essentially, these paratimes are blockchains, let's say, and they have specific purpose. For example, EVM compatible blockchain, which is called Emerald ParaTime, has a focus to provide full support for EVM compatibility. So to have some easy integration with EVM-based dApps, for NFTs, for DeFi use cases, and so on, right? And then we have other paratimes, for confidentiality, for example, maybe for some data let's say management, with analytics, with encrypted data. So it's more used to, let's say, enterprise, where you have some permissioned enterprise ParaTime. Okay, so this will be a parcel SDK if you want. Okay, now we will focus on EVM compatible ParaTime, and this EVM compatible ParaTime is called Oasis Emerald ParaTime. Okay, let me go first what the EVM compatible chain is. Okay, if you're wondering why we have so-called Ethereum virtual machine compatible blockchains, so there must be some reason, right? And these reasons could be, of course, that Ethereum can process, only 15 transactions per second. So imagine having thousands of dApps, thousands of transactions. You will get some congestion, right? And you will have some high transaction fees. That's almost, not the only reason, but the major reason why we seen this boom explosion in EVM, supported blockchains, right? So essentially, EVM, it means Ethereum virtual machine, which is essentially virtual CPU for Ethereum to execute some code of smart contracts, our Solidity smart contracts. So EVM, it's like a new blockchain. So imagine if we have Emerald, ParaTime as an EVM, supported blockchain. It means that we have a new blockchain with much lower transaction fees and much faster settlements. Okay, so that's what we get with, for example, EVM blockchain called Emerald ParaTime. Okay, now EVM compatibility, on the other hand, is actually that you can create or execute the same code or the same smart contracts, the same dApps, if you want, just as on Ethereum, right? But that's why we have so easy transition, so easy, migration from Ethereum to EVM blockchains such as Emerald. So we benefit not only from transaction cost, but also from faster transactions, faster confirmations. And at the end, what does that mean? It means better user experience. And that's what we all want, right? As a user, I want to have smooth experience, fast NFT minting, fast transactions on DEXs, easy, fast, lending, borrowing on decentralized apps, right? So this is why it's very important to have EVM compatible blockchain such as Emerald. Okay, so yeah, that's what I already pointed out. It's very easy to migrate, any smart contracts or code from Ethereum to any EVM compatible chain, in our case to Emerald. Okay, now when we know now what EVM compatible chain is, now we can touch, Emerald ParaTime. We can see what Emerald ParaTime is capable of, right? So first of all, Emerald ParaTime is full EVM compatible blockchain. Okay, which means that you can do basically everything that you can do on Ethereum also on Emerald, but with much lower cost, with much lower fees compared to Ethereum. For example, we have only, for example, gas price 10 nanoros, which is very, very low, almost zero. But at the same time, you can use the same technology, the same tools, the same language that you were using on Ethereum, for example. So smart contracts will be the same, written in Solidity. So you will have these .sol smart contracts to be deployed on Emerald testnet or mainnet. So you can use Emerald, for any, let's say, DeFi project, for NFT project, for so-called Web3, right? So you can call any use case from, crypto gaming, from, metaverse stuff that you play to earn and so on, right? There are a lot of trends, coming to the play. Now, It's scalable because we have our architecture, split into the consensus layer 1 and layer 2 to do the ParaTimes. So we have really, really scalable architecture here. And the block time is same as consensus essentially. So if you check also on Block Explorer, you will notice it's 6 point something, so around 6 seconds, which is amazing, right? For EVM compatible blockchain. Now, we also want to point out that our Emerald network or blockchain is fully decentralized. Nowadays there are approximately 56 Oasis ParaTime nodes, but we don't run anything. So it's fully professionally, let's say, run of Oasis nodes, and also by community. Okay, so you can run your Emerald ParaTime node if you want, but essentially you will have to be elected and so on. I will show you more incentives on the next slide. And keep in mind that we are using Rose as a native token on all the, on the consensus layer, on Emerald ParaTime, on Cypher ParaTime. So Rose is core token here. Okay. Now, going to, some incentives to run Emerald ParaTime node. Okay. So we want to make sure that this network is fully decentralized. Okay. So anyone can run a node. And these nodes are distributed globally. So whenever you can run a node. You can run it, on cloud or privately if you have servers and so on. But essentially, how you will do that? Well, of course, just like with any node, but you will also get rewarded for that. Yeah. So usually we have some mechanism how that works. And our ParaTime actually releases these tokens, Rose tokens on chain to reward all the node operators. Okay, so usually that's how it goes. There are 3 Rose tokens per entity per epoch, which means that one epoch is 1 hour. So essentially, if you have 3 Rose per hour, it's like 72 Rose per entity per epoch, right? In 24 hours. So what does that mean? It means that also there is a mechanism who, will be able to claim the rewards. So it means that not all the time same validators or same nodes are eligible to claim. So you have 30% chance to claim these rewards, which essentially means that you get 24 rows approximately per day. And if you calculate and multiply that by 30 days, approximately 1 month, you will notice that this is around 720 rows per month. So there's an incentive to run this node, which essentially means that you don't have any costs running this node because you get rewarded for that. And at the end, if you have some delegations and so on, if you have enough people using your node and so on, you also get some fees, and you can actually profit from that. All right, so I will stop here with first module. I hope it was interesting, and we see you in the next one. Hi, welcome to module 2. My name is Gasper, and I'm developer relations lead at Oasis Network. In this module, I will show you how to transfer some assets from different chains to Emerald ParaTime. Not only Rose token, right, but also, let's say, ETH, USDC, USDT to our Emerald ParaTime. Also, if you want to get, smart contract addresses, if you want to verify which tokens are actually legit and so on, we will need to use some block explorers for testnet and for mainnet. So let me begin with how to transfer some rows to Emerald ParaTime. We already did that in the first course, but let's keep that only with rows to Emerald ParaTime now. So you will need Oasis Wallet browser extension, where you can deposit your rows first on consensus layer, right? So essentially, you want to get or receive the rows on consensus layer first. So you can buy, let's say, some rows on, I don't know, exchanges that support buying rows. Then you withdraw that rows to consensus address, right, into your browser extension. And once you have all these rows that you want to transfer to Emerald ParaTime, you can actually use, ParaTime tab, which I actually selected on the first screenshot, and then you click to ParaTime. This will actually enable you to enter the amount of the rows you want to transfer to specific, Ethereum compatible address, which is essentially used on Emerald EVM blockchain. And then you will confirm, so you will click next and confirm the transaction. And you can then go to, for example, to your MetaMask, where you have your Emerald ParaTime mainnet network added. And you should essentially see the rows that you just transferred from consensus to Emerald ParaTime. So that will be pretty straightforward. You can do the same in the opposite way if you want to transfer some rows from Emerald back to consensus. But you will then go to, instead of ParaTime and to ParaTime, you will have to switch your account to Ethereum compatible account. And then you will have an option to send back to consensus. And this button will appear enabled, and you will be able to send to consensus. Okay, so that's how easy it is to transfer rows from consensus to ParaTime and from ParaTime back to consensus. All right, so what if you have some, for example, other asset, not rows? Well, for that reason, we cannot use, only wallets, for example, our wallets, official wallets, or even MetaMask, but we need to use some services, some so-called bridges, where we can bridge assets to Emerald ParaTime, okay? Which essentially means that you need to, use, for example, Portal by Wormhole. So it's portalbridge.com or bridge.seller.network. So these are two different bridges that can be used to transfer assets to Emerald, right? Now, first, you will have to enable or, configure your MetaMask, or even if you're using Brave browser, your Brave wallet, with Emerald network, and then you can go to these bridges and just select what's the source chain or source network from which you want to transfer or bridge assets to Emerald. Okay, so you can actually select Ethereum, I don't know, Binance Smart Chain or Avalanche and so on, right? Polygon. You can actually select the source, and then as a target you will select Emerald or Oasis. Okay, what will happen next? You will follow the steps, connect the wallet, confirm the transactions, and so on. And after a few minutes, you will have your assets on Emerald ParaTime. Okay, so that's the way how you transfer other assets than rows to ParaTime. Okay, now once you will have your assets on ParaTime, on Emerald ParaTime, you will be able to use some Emerald block explorers to verify if you have your assets on your account, or if you successfully do transaction, if you successfully received, let's say, USDCs or whatever it is, right? So to do that, we have two explorers. Now, keep in mind that usually when you will be using the real dApps and so on, you will use explore.emerald.oasis.dApp. Okay, so this is our mainnet explorer for Emerald. But if you will be testing something, if you are a developer and so on, you will use testnet.explorer.emerald.oasis.dev. Okay, I know, it's long, but it works smoothly, and it's meant especially for Emerald. So keep in mind, it's not meant for consensus, it's meant for Emerald EVM blockchain. Okay, now what you will be able to see here you will be able to verify your address to see the account status, how many tokens you have, if you have any NFTs, if you have, for example, some transactions, and so on. Okay, so essentially, block explorers are meant to dive deeper on everything happening on blockchain, in our case on Emerald, and to verify what happened with your address, with some specific transaction, and so on. Okay, so this is all verifiable, and Emerald Block Explorer offers you to do that and verify and to ensure that everything was actually like you planned and that transactions were executed successfully. Okay, now that's everything for module 2. The most interesting module is coming right after this one. Thank you for being here and see you in the next one. Hi, welcome to module 3. My name is Gasper and I'm Developer Relations Lead at Oasis Network. In this module, I will show you the most popular tools used on any EVM blockchain to deploy, to develop smart contracts on testnets, on mainnets, and essentially to build your projects. So let's dive into it. First, you have many options how to deploy dApps smart contracts on any testnet or mainnet. One of the options is that you set everything on your own. So you might be, more familiar with your environment, or you want to manage all the things on yourself. So essentially, you will configure your local environment, right? So basically do it yourself. So what you will do, you will go to, GitHub, you will download Oasis SDK. Inside Oasis SDK, you will find Oasis CLI. And you will use Oasis CLI, for example, to configure the networks, so essentially the testnet and mainnet, and also to configure ParaTime parameters. Okay, so on this screenshot, you will notice that I list all the networks available. So essentially, I have mainnet and testnet, and you see when you will compare that, IDs if you want, and RPCs, you will notice that I have, for example, Emerald testnet configured and Emerald Oasis Dev as a mainnet. Okay, so with Oasis network list, you can see which one is the selected currently, which means if I will deploy something, it will be on testnet. Now, if I go to Oasis ParaTime, you see the commands available. I can even add a new ParaTime if I want, right? I can remove paratimes. So you can develop your own paratime essentially. But what I want to do is I want to set the default paratime used in my local environment. So if I list, for example, paratimes, so I will say Oasis paratime list, I will see all my paratimes. So I have Cypher, I have Emerald, I have testnet, I have mainnet, right? And I can see which networks or which paratimes are selected. So for mainnet, there's Emerald. For testnet, there was Cypher, right? So what I want to do is I want to change the testnet paratime to Emerald. So I will say Oasis paratime set default and testnet to Emerald. Okay, with this command, I actually get what? That my testnet now is Emerald and my mainnet is also Emerald. Okay, so that's the result of the first Oasis network list command. Okay, so there are some prerequisites for that. You must have npm, so you must have some package managers, right? And npx. You must have Node.js. You must have a code editor. You can use anyone, for example, brackets or whatever you're using. And you need terminal, right? So all these things together can enable configurations, for your local environment. And once you have this, you can develop, you can, create smart contracts and then deploy to network that you have, right? So in my case, testnet on Emerald. Okay, if that's too much, if you want to start quicker than that, we have a very convenient way, and there is a Docker image for you. So you can go to Docker Hub, you can Google, not Google, but you can search for Emerald-dev. You will get the latest, so you can download the latest Docker image, which essentially will spin up, some local Oasis stack. What does that mean? You will get your local private Oasis network, right? With all the components needed to test, the whole stack or your dApp. So what you get is actually one validator node with only 1 second block time. Then you get 3 Oasis compute nodes which are running Emerald ParaTime, and you also get Web3 gateway with some transaction indexer, okay? And of course some help scripts which populates then initial test accounts. So when you will run that image, you will notice that there are several accounts populated, you get private keys and so on. So it's pretty cool because you can actually do everything locally, okay? So this is the second option. If you want to go and maybe, deploy faster, on testnet with some tools like Truffle, you have that option too. So first of all, you will have to install Truffle. So when you will set up when you will install Truffle, you can run some commands, right? To ensure that Truffle project will be, let's say, unboxed first, and then you can manage smart contracts and configuration file. Now, essential part when developing with this kind of tools is to get into, each of these tools configuration file. In Truffle, that's truffle-config.js, okay? When you will open this file, so you can do it, with VI or on the VI command, or if you have any other commands inside your terminal, or you can do it by just, navigating to this folder in your Explorer and then open that file in your, code editor, and then you can change the parameters, okay? So what you will have to do is to change or add network parameters for your Emerald testnet, mainnet, or even for local environment. So remember, if you will be, using Docker image Emerald dev, you will spin up local Emerald network. And if you want to deploy something on that local network, just make sure that you will add Emerald_local, for example, network, okay? So you will be able to deploy there, okay? Now, once you will configure your Truffle, JS file, you can then run some tests of your smart contracts, and if you want to deploy smart contracts, you can actually use this command, truffle test -- network, to specify on which network you want to deploy. So currently I was deploying some test project on Emerald testnet, and you see the first thing that it's done is actually compiling of your Solidity smart contracts, and then they are essentially deployed to the testnet and also tested at the end. Okay, so this is just a Truffle example, but yeah, you can do that, or the same thing with your own project. Now, very similar, if almost not the same, let's say very similar, is developing with Hardhat. Okay, Hardhat is also popular developing on Ethereum or EVM blockchains. You have also the same principle, the same logic. Okay, you will have to configure hardhat.config.typescript file, yeah, with our network parameters. So essentially, you will have to add Emerald testnet and mainnet if you want to deploy on testnet or mainnet. But if you want to develop on your local network, if you are using, let's say, your or our Docker image, you will also have to add this Emerald local the URL, and so on, right? So that's pretty cool. Save that configuration, and then you can start with deployment and tests. So there is a bit different command. You can do npx hardhat run, and then you have this script for deploy. So there is a script, deploy type script, and define on which network. So I selected -- network, Emerald testnet. If you want to deploy and test this on local, or maybe even on mainnet, right? Just change that destination network. Okay. So now the smart contracts will be compiled and uploaded or deployed later on testnet in my example. Okay. So now I will do the npx hardhat test network Emerald test, and you will notice that I actually deployed that on testnet, and the tests were actually successfully passed, or were successful. So not a big deal, but very similar tools. You can choose any one that you prefer or that you will prefer, because all the options are there. Last but not least, guys, is that you can use Remix, which is essentially the IDE or a web tool, if you want, which you can use for, let's say, some fast deployments, ad hoc solutions, and so on, because essentially you provide some smart contract, so some code, .sol solidity contract, right? And then you compile that. So we have actually a few, not buttons, but in the menu you have few options to compile, to deploy, to run transactions, and so on, right? So first you will go to compile. That's actually the second icon here. And once you will compile with the right solidity version, so that's this pragma solidity, right? Once you will compile that, you can go to deploy and run transactions. So that's actually the third icon, where you will select essentially the injected Web3. Why? Because you will be using your MetaMask to confirm transaction for deployment, and also to inject, or let's say to select, your Emerald or testnet or mainnet. Okay. So you will select this injected Web3 with the custom network that will be your Emerald testnet or mainnet, and then you will connect your account. Okay, so then you will be able to use MetaMask to connect your development account. And then once you will confirm that, you can click deploy. So don't forget to select the right smart contract. So their contract must be the right that you want to deploy. Okay. Now, once you will deploy that, you can actually start testing your smart contract, confirming transactions to see the responses. Okay. So we will have this, demo deploying so first of all, we will have a demo with Truffle, and later on I will show you also one example how to develop some things with Remix, and that will be our actually Bent Oracle smart contract integration. Hi, welcome to module 4. My name is Gasper, and I'm developer relations lead at Oasis Network. In this module I will explain and show you how to integrate Bent Oracle smart contract to Oasis testnet or mainnet, and how to use some real price, let's say wrapped ETH versus BTC, or BTC versus USD for your dApp. So let's dive into it. First, I want to show you and explain what Bent protocol is. So Bent protocol is a cross-chain data workload platform that aggregates and connects real-world data and also APIs to smart contracts. Okay, what does that mean? It means that you actually can get, prices from different chains or smart contracts, connected together via APIs. So a lot of functionalities via Bent protocol. not only for prices, but also for sports scores, for flight statuses, for weather information. So a lot of cool stuff, available via one protocol called Band. So this Band protocol, or let's say this Oracle, was actually built on top of Band chain, which actually has this Cosmos SDK based blockchain. Now, this Band protocol will allow developers to query this on-chain data. And again, this on-chain data can be a lot of things. We will focus on token, or not only on token balances, but more on token prices, or asset prices, because we will have, let's say, example for BTC versus USD, ETH versus USD, to get these prices in real time. Okay, so that's what Band protocol is. Now, let's jump into how to do that. Remember when I mentioned that we have several tools that can be used to deploy, to test, to do something with our EVM chains. And today I'm gonna use Remix to show you how to do that Oracle example. So first of all, you can actually go to our docs.oasis.dev, and we have this guide for you. So it's actually integrating Band Oracle smart contract. So what you will do, you will open the link that will redirect you to Remix, which already contains and includes this smart contract that you can see right here. Yeah. So this is the version of the Solidity language. So we actually use, that's an example also that you can see and find on Oracle. On the Band. And this is 6.11, and that's why we will also need to use the same compiler for that. Okay, so don't forget, when you will open Remix, on the left side you will have like a menu where you can select the Solidity compiler. Okay, so that's the first menu, or the first section when you need to compile your smart contract. Okay, so to do that, you will have to choose the right compiler. So the versions must match. And once you will match the versions, you can simply click compile. Okay, so what kind of smart contract will you deploy? If you check a bit down there in line 25, you will notice that the name is actually Demo Oracle. You can change that if you want, but essentially that's what we will deploy. That's what our smart contract, or that's actually the name. Yeah. Okay. Once you will compile that, I can actually go to the second, let's say, icon or functionality of Remix, which is actually deploy and run. So essentially, you can deploy your smart contract to testnet or mainnet, and then you can run some functions. So let's go, step by step first. Now, when you will check the smart contract, we mentioned that the name is actually Demo Oracle, and if you go down below, we have some constructor that will actually save or store our, let's say, address where we want to deploy. So we will have to provide some, address there on the left side then. Okay. And then after, you see functions, get price function, get multi prices, and down below you will also notice another function, save price, and so on. Yeah. Now, essential part of this smart contract is that we will get the reference data, and if you check the get price, you see we will get rep BTC versus USD. So we call that rep BTC is like a base, and then we have like a quote. So we have rep BTC versus USD, just like on exchanges or on DEXs when you have these pairs. Yeah. Okay, so essentially we will actually show the rep BTC price expressed in USDC. Yeah. Now, to do that, to deploy that to our testnet in our example, you will actually select the environment first. Okay, so environment must be injected Web3. Why? Because you want to select, or you want to use actually MetaMask to select the right network and to confirm the transaction to deploy. Yeah. Cool. So once you will, select injected Web3, you will be able to use a MetaMask where you will actually select, let's say, Emerald testnet or Emerald mainnet, and then of course also select and connect the account. Okay, so the account which you will be using to deploy. Okay, so I will select my demo account, and then down below you will notice a contract section. Under this contract section, make sure that this is the smart contract you want to deploy, because you might have multiple smart contracts, and make sure that this is the one you want to deploy. Then you will notice this deploy button. Okay, this deploy button and this constructor right here, so this is actually an input field for this constructor, is actually a reference for our band data aggregator contract address. So essentially, if you will be deploying that to testnet, there is a testnet band reference data aggregator contract address. Okay, so you will find that address on our web page, on our docs, because it's a different than to the mainnet. Okay, so provide the right smart contract address. Cool. And once you have these parameters correctly fulfilled, you can click deploy. Okay, so once you will click deploy, a pop-up will appear where the MetaMask will actually ask you for confirmation, and then you will deploy smart contract. Okay, then smart contract will be online on testnet or even on mainnet. Yeah, and then what can you expect is to use some functions or to use some functionality of this smart contract on our testnet or mainnet. Okay, so for that reason, you can scroll a bit down in Remix and you will notice there is a deployed contract section where you have some functions included from the smart contract, okay, which you can actually test live with Remix tool. Okay, so that's why we will first try to, you can click actually on get price, and guess what? Get price will just return rep BTC versus USD. And voila, if you click that, you will notice that there was a number, there was a price, probably 39,500 and so on, right? So it's just the real-time data that comes from that Oracle, okay? You can also test multi-prices. Guess what? You will get rep BTC versus USD and ETH versus USD, okay? So this is what it comes out when you press the button, let's say function get multi-prices. You can of course call that from your app, but this is only, let's say, ad hoc or fast execution to see if it works like it should. And when you press these buttons, let's say these functions, you will also see calls in real time and the results. Okay. Keep in mind that some data that will be shown here actually includes, or the rates will actually be multiplied by 1 on exponent minus 18, right? So consider that you have to, if you want to get the real price like 39,000 or something, you have to multiply by the right number. Okay, so that's just one specific about returned results. Okay, so that's where I will finish my slides, and I will show you the demo how to do that and how to test that. Thank you for being here, and see you in the next one. Hi, welcome to Module 5. My name is Gasper, and I'm Developer Relations Lead at Oasis Network. In this module, I want to show you how to create and deploy NFT smart contract, how to store your art or metadata on decentralized storage, and how to mint an NFT, or actually ERC 721 token. So let me begin with the first, what actually NFT is. So compared to fungible tokens, these NFTs are non-fungible tokens. So if you compare fungible to non-fungible, it means that you're comparing, Ethereum, Rose token or BTC token. So these tokens are interchangeable. Okay, so one rose is one rose, one ETH is one ETH. While if you compare the non-fungible tokens or NFTs, they are unique and each one is different. So you cannot really exchange, let's say, one NFT for another that has the same values, the same metadata, so the structure or the characteristics of NFTs are completely different. Okay, so that's why you cannot call them interchangeable. So every token every single ERC-721 token has unique characteristics and metadata and also different values. So what does that mean? This token standard ERC-721 describes how to build these NFTs on any EVM compatible blockchain actually. So what you will notice in this open standard are some functions, right? Some functionalities, parameters. Usually you will find some, name of the NFT, symbols of NFTs, how much the supply is, the balance of, some other ownership functions or metadata functions or even events. So all this is described in this standard. And if you want to read more, let's just Google ERC-721 and you will get the whole documentation. Now, keep in mind that NFTs are not only ERC-721. NFTs can also be, ERC-1155 tokens, right? So we have different types, but more or less we're talking about ERC-721 and EVM blockchains are the ones who support these NFTs. So you will find the same type on Emerald, our EVM compatible blockchain network. And there are some examples, our AI Rose, maybe Oasis apes and so on. Okay, that's pretty cool. Now, let's take a look how to create these NFTs. Okay, so you will be able to help your maybe artist, your friend who can do some art. If you're a developer, you will support his work to deploy some NFTs on Emerald, for example. So first of all, which components do you need? First, you need to have some decentralized or some storage. Okay, we will see what we will use for that. Essentially, you will notice that you need some service called IPFS. So you either use, you have different options, desktop or CLI, but I will show you the CLI option. And then you will be able to use that IPFS to store your art and metadata. So basically that will be your storage, let's say. And then you can also connect this IPFS to third-party providers for storing that, let's say, online to be always available and so on. I will talk about that very soon. So first, you need to install IPFS. So you can do that with CLI and then you can start IPFS daemon. So first of all, you can install IPFS CLI. Basically, the Go IPFS will show in your folder locally. So you can do the, you can go to this Go IPFS, then you have some IPFS init command, and you will notice that it will start the repo for you, and then it will start a daemon with IPFS daemon command. Okay, and once you will see the daemon is ready, you can open a new tab in your terminal window, and you can start working with that storage. Okay, so first make sure that the daemon is running so IPFS is ready to use. Next, you will prepare the NFT files. So usually what comes within the NFT, right, is art. So basically some image, it could be PNG, right? And then also some metadata. Usually, the best option is to provide the JSON file where you can have some configurations, links, descriptions, parameters, and so on. Yeah. So that's why we will have, for example, two files. We will have art, NFT PNG, for example, and you can provide the NFT JSON with metadata. So these are two examples, okay? Now, from this folder, you can add these files to IPFS. IPFS will make them, let's say, available for smart contracts and so on, okay? So first, we will add these files to IPFS. So to do that, you can actually use IPFS add NFT PNG. So basically IPFS add and then the name of the file. So I have NFT PNG, and I can also say again IPFS add and then NFT.json. Now, remember one thing. Every time that you will add some files to IPFS storage, you will get so-called CID. That's actually the identifier of that file, okay, that you are actually adding to IPFS. You will need that ID later on to build, for example, URLs and other stuff. Okay, so keep that IDs, let's say in a clipboard or at least in some notepad. Now, let's go to pin some files now to remote decentralized storage. So IPFS will not make everything publicly available. So for example, if you want to publish an NFT to be available, to someone in a different area, let's say in Europe, in USA, in Asia, you will have to pin those files to remote services. So I suggest using some of these, most popular, I would say, services like NFT storage, which is free, by the way, and also Pinata, which is also free, but it's limited because if you have a larger project, they have some pricing involved. Now, the first one looks like that, NFT storage, and Pinata like that. Essentially, they provide the same functionality. Basically, it's like a repository or public repository for your files on blockchain, or let's say on the decentralized storage. So if we take a look what you need to do, right? Now you added these files to IPFS, but you will have to now, let's say, add one of these services to your IPFS. So when you will pin some files to remote service, they will start, they will be available, let's say online, wherever you go. So basically on the internet, on the World Wide Web. Now, to add remote pinning service to IPFS, you can use this command. So it's IPFS pin remote service and then add. Then you will need to provide service name. This service name is your name. You can actually say, I don't know, NFT storage or Pinata, whatever that service is, and then API URL. This API URL is actually specific to a service that you will be using. Go to check documentation because they have some specific URLs, okay? So provide, let's say, NFT storage URL here, and then provide your authentication key. So what's that authentication key? When you will register on NFT storage or on Pinata, you can actually go and check you will create the API keys, okay? So once you create your API key that will be connected, let's say, to your specific reason for this IPFS service, you will provide this key right here at the end. And then you will execute this command. And after execution, now IPFS will have this remote service that you will be able to pin files to this remote service. And then you can start pinning these files to remote service. So again, the logic is to add files to IPFS and then pin them to remote service. Okay, so to pin files to remote service, what essentially that means is you will actually upload and store these files into the remote, let's say, decentralized storage. So when you do the IPFS pin remote add, you will provide dash that service and then service name that you used before, and then dash name for pin name. What's that pin name? You actually need to provide a file name, and then you see that CID, that's the ID when you added your files to IPFS. So essentially you can say pin name, it could be NFT JSON or NFT PNG, and provide the identifier for that art or for that JSON file. So that's important. And once you will do that, files will actually appear on this decentralized storage. So essentially you will see the files in NFT storage or Pinata. Okay? And then you can access those publicly from whenever you want. And whenever, wherever. So it's available. Okay? So that's pretty cool. The next thing, so now you have your files ready. Okay, they are not on chain, they are not on Emerald, they are not, minted. There is nothing, just files are waiting for you to mint them. Okay, so next step is to deploy NFT smart contract. NFT smart contract can be very simple if you are minting only one, let's say NFT to one specific address. So we will have this example. We are using actually, there is a code on GitHub. It's from Nipstack. So this is what we will import and use, and then we will create a new contract called new NFT. You can actually change that if you want, but essentially that's a name that we will use for the smart contract. And you see the NFT name is actually, you can use, I used gas per NFT, but you can use also, I don't know, my first NFT, or I don't know, the gas per ape, or whatever the NFT name you want to provide, and then a token name. So remember, that's actually the ERC 721 token name. So that's how it will appear on Explorers, okay? Or in your wallet if you want. So yeah, I name it test NFT, okay? And then once you have these parameters in the smart contract, you will deploy that to testnet, for example. So I will actually choose the environment injected to Web3. So I want to actually connect my MetaMask. That's why I choose that, and to have my testnet, or mainnet for Emerald selected. Then I will connect my account, which actually will be, posting or deploying that smart contract. And then I can actually verify that the contract I will deploy is the same I name it. Okay. So before you actually deploy, you have to compile first. Okay. Don't be confused. So first compile and then deploy. Okay. So then you can deploy your smart contract, confirm the transaction. Okay, and once you will confirm the transaction, the smart contract will go live on testnet to that address that you're using, with MetaMask. Cool. So that's pretty awesome. Now you have files, you have JSON, you have PNG, art, you have smart contract live. Now what? That's the interesting part. That's where we get some cool stuff going on. So now we will mint an NFT on Emerald. Okay, we will still be using this remix tool, and we will mint an NFT now. So how to do that? We will use our smart contract, our deployed smart contract, and our files. Okay, so it's that simple. So down below, after you will deploy that smart contract, you will be able to expand this deployed smart contract functionalities. Okay, so you will find this new NFT smart contract, and there is mint function. Yeah, you will have to provide 3 parameters essentially. Okay, first you will add your Emerald address to the to field. This is actually where I want to mint an NFT. So the holder of this NFT will be that to address, and then on the second token ID, you provide let's say the token ID, usually starting with 1 if that's the first NFT. If that's the 9099 NFT, you put the ID like that. Okay, so essentially that's a unique identifier of this token ID. Now, the last but not least is URL. What's that URL? That's actually URL you want to have on blockchain. So you want to have in this metadata or in this raw input if you want. So this URI, I prefer to include here JSON URI, or even the NFT storage can merge, let's say, all the files and give you only one URL. And that's why I also preferred, let's say, NFT storage. And then inside that you have JSON and PNG file. So, for example, just provide this publicly available address where your files are. Okay. So essentially, before, when you upload them or when you pin them to NFT storage or Pinata, provide the URL from this service. Okay, and once you provide all three parameters, you can click transact, and then you will confirm the transaction, and guess what? Voila, this will appear. Okay, so that's awesome. You can then verify your minted NFT. How? Well, you will need the Emerald Block Explorer, so you can use testnet Block Explorer or mainnet Block Explorer, and you enter your address. So usually the address that you used for field or your address where you mint NFT, right? So you enter that address, and if you scroll down below almost to the end, there is a raw input field or parameter, and you will change that. From drop down menu you can actually choose UTF-8, because you can copy then that URL that you actually, let's say, publish as a token to the public blockchain, to our testnet or actually mainnet, and then use that URL, and voila, you guess what? That's the address where you hold your PNG or JSON. Cool, right? And then when you click on that file or this file, okay, you actually get the art, or you actually get the JSON file, which you can use then, to present on a new fancy web page or do whatever you want with this, JSON file, which is structured and can be easily used in a programmable way, to do some maybe fancy marketplace or something like that. Pretty cool, right? So that was the end of my presentation for NFTs. And what's coming is actually a demo how to do that. It's pretty simple like we described. So if you're interested, see you in the demo and in the next course. Thank you and see you soon.